Alright, so this is Geometry, Semester 2. It's the unit on surface area number 6. It's the third lesson within that unit on surface area of cylinders and slant cylinders, otherwise known as oblique cylinders. O-B, oblique, I-Q-U-E, oblique. Alright, this is from creatormath.com, and it's under the Geometry tab. That's where you're going to go. You might have to put in creatormath.weebly.com. The instructions for students are copy the following problems into your composition book on the correct pages according to the table of contents, with the notes for those pages from creatormath.com. Remember, the notes are under a separate link there. Just click on it, it says notes, it'll open it up. That goes on the correct page, and then these problems go in with it. All right, so this says, given the following three-dimensional shape, what is the surface area? So this is a cylinder. A cylinder is like a can of Coke, right? You draw it by doing a oval, and then a bottom line, and a belt across the back, and there's your cylinder. The cool thing about a cylinder is, if we were to, say, cut this side of the cylinder, put a cut down it, and then unroll it. If you unroll a cylinder, it's going to be a rectangle. At both ends will be a circle, like this, and like this. Get a little bit better circle. And so if you close those two circles down, rolled it up into a three-dimensional shape. So what we're going to do is take this rectangle, we're going to find the area of that, and we're going to take each of these circles, well, one of the circles, find the area, and then just multiply it by 2, because we have 2. That'll give us the surface area, the area all around the surface of the shape of the Coke can. So what they're looking for here is the idea that if you had this length, this circumference, that would be the length here. And we know the height, so that would be the height. So we can find the area of this by length times height. And the length in this case would be circumference. And circumference is another word for perimeter, but we use circumference when we're talking about a circle, the area around a circle. Ference. I can't spell circumference. There it is. And I wrote it very badly. Sorry about that. Well, so what they're looking for is the circumference of the end shape, in this case a circle, times the height of the shape, because that would be this dimension here, plus 2 times the area of the end shape. So we get one of these areas of the circle, multiplied by 2, we're going to have this. So they're giving us just a general formula here, but it makes sense to us, and we're going to use it on all the other shapes we do, and you'll find out it's surprisingly consistent. Let's look at the next problem. So this is a cylinder also, but it's oblique. Oblique means pushed over. Notice that the top and bottom, were parallel like this, and they were stretched this way. They didn't slant. It's not just slanting the shape. It's actually stretching the shape out in a lateral manner. So this is called oblique. This side stays parallel to this side in terms of the planes they're on. And we're dealing with a height here. That note is at 90 degrees to the base. This is a perpendicular height. So given the following three-dimensional shape, what's the surface area? So what they're trying to show us is it's exactly the same for an oblique shape as it is for a non-oblique shape, with the important part that we're talking about a perpendicular height. We probably did not define this up here as perpendicular, but it is. And notice that becomes a little bit more critical when the shape is slanted over. We're not talking about this distance, we're talking about this height from here to here. Perpendicular because it's 90 degrees to the base. The circumference of the end shape, which in this case is a circle, times the perpendicular height, that'll give the area of that inner rectangle, and then 2 times the area of the end shape. So exact same formula, so to speak, just making sure that in both cases we're dealing with a perpendicular height. All right, given the following three-dimensional shape, what is the surface area? Well, now they're actually dropping in a formula for this thing. So we have for us circumference of a circle, which is 2 pi r, times, I'm going to put perp height, which is perpendicular height. Okay, plus 2 times the area of a circle, so 2 times pi r squared. And that's it. That's the formula for finding the surface area of the shape. Here, notice we have 2 pi r times the height of the shape. They didn't say perpendicular height, and that's maybe a little bit more relevant when we get to the oblique shape next, times 2 times pi r squared. So pi r squared is the area of one circle. 2 times that would be the circle at the top and the circle at the bottom. Now they're going to give us an oblique shape and show that as long as we're using a perpendicular height, and this says height of the shape, I really would have liked them to say perpendicular height here. Perpendicular height, and maybe I will change that before you even get to this assignment. Alright, so I would like that to say perpendicular height. So here we go, and it's 2 pi r squared. That's the same thing. Otherwise, illustrating to us that as long as we're dealing with the perpendicular height, it doesn't matter if it's an oblique cylinder or a non-oblique cylinder, the surface area calculation is the same. All right, we've talked about the formula a couple of times and the idea of how it's produced. Now it looks like they're going to give us some dimensions here. It says if the radius is 4 feet, so here's the radius here, 4 feet. And remember, the opposite of radius, not the opposite, but radius is from the center to the side, diameter is across the long length. I help my students to remember that by come up with some word that D stands for that's bigger, like dinosaur is bigger than R, which is rat. So dinosaur is the longer dimension. And it is interesting to me that I'll have students who clearly have learned radius and diameter, but they still, those terms become muddied in their mind, and they often mix them up. They often don't realize the simple relationship that 2 times the r equals d, or d divided by 2 equals r. Even that in itself can be quite complicated. So we've got 4 feet here. What's the height? Height is 10 feet. What's the surface area? Well, we've got the circumference, 2 pi r, times perpendicular height, 10 feet. Plus 2 times the area of the circle at the end, which is pi r squared. So I started to fill this in. This is perpendicular height. 2 pi, 4 feet, leave the units in there. Now times the 10 feet, leave the units in there. Plus 2 times pi r squared, which is 4 feet, keep the units in there, square it. 2 times 4 is 8, times 10 is 80, and there's a pi. So I have 80 pi. Feet times feet is feet squared. Good, because it's an area, we need feet squared. 2 times 4 is 8, and there's a pi, so there's an 8 pi. Feet times feet, or feet squared, is feet squared. Good, because when we add these, feet squared and feet squared need to add. So we have 80 pi plus 8 pi, so 88 pi feet squared. I'm going to leave the pi in it because it's more accurate. I know it stands for 3.14, but it also stands for 3.14159.265, and on it goes. So by leaving its symbol pi, we carry all of the infinite digits with that value. So it looks like they didn't even multiply it out. 2 pi, 4 feet, 10 feet. That's this right here. Check. And 2 pi, 4 feet squared. Check. Piece of cake. They don't even make me multiply it out. Here they're just proving to us the same thing, that if we're dealing with a perpendicular height of 10 feet, well, they did change the radius on us here. They said this is 5 feet here for the radius. It was 4 on the last one. So let's go ahead and say 2 pi r, that is the circumference of the top, times the perpendicular height, plus 2 times the area of a circle, which is pi r squared, 2 pi 5 feet, carry the units with it, times the height 10 feet, carry the units with it, plus 2 pi r squared, so 2 pi and 5 feet squared. 5 feet, carry the units with it, and square the whole thing, including the units. So do they even make us multiply it out? Nope, we got a 2 times a 5 times a 10. 2, 5, 10, and a pi, and a feet, check. And a 2, a pi, a 5 squared. Oh, they didn't even make us square that. Right, if you had to square it, it'd be 5 times 5 is 25, and feet squared is feet squared. You still have the 2 pi in here. 2 pi, 5 feet, 10 feet, right? 2 times 5 is 10, times 10 is 100, so 100 pi feet squared plus 2 times 25 is 50. 50 pi feet squared. Combine them because we add them, and you get 150. Don't forget the pi feet squared. So it's this answer. That's the one they're looking for. This is, match up the title carefully. This is Geometry Semester 2. It's the unit on surface area number 6, and it's the third lesson in that unit, surface area of cylinders and oblique cylinders practice. And it's on creatormath.com or creatormath.weebly.com under the Geometry tab.